Right. Good afternoon, everyone. My name is Tony RIEMER, and I'm here to present the IDEAL network. IDEAL is the interoperable, decentralized entropy aggregation layer. Over the past year or so, we've been working alongside the Web3 Foundation, where we've proposed and completed a Web3 Foundation grant, as well as, or one of the first participants in the Decentralized Futures program. So big thanks to Web3 Foundation. This really wouldn't be possible without them, and also PBA, which we're all graduates of. So I want to get started with discussing what is secure randomness, why is it important, and why you should care. So by secure randomness, I mean patterns that you can generate but can't predict and that you can't manipulate. So even given the entire history of something, you won't be able to guess or predict what's going to come next. And it really plays a fundamental role in almost every aspect of cybersecurity, from secure communications, key generation. Pretty much most Web3 protocols require randomness in some aspect, at some layer, usually the most fundamental ones. But the problem is we're not very good at it. People aren't very good at generating or using it. For example, OWASP ranks randomness or insecure randomness as the 8th most common flaw Web3 developers make when implementing smart contracts. And this is a really big problem because it's easy to exploit these types of things to manipulate the outcome. But the problem is financial costs of insecure randomness can be really, really high, reaching the millions or more. And this is because generating randomness is really hard. True randomness is even more difficult, and computers are inherently deterministic systems, so they really can't generate their own randomness. And by inheritance, so are blockchains. And there are certain protocols you can use, trusted, centralized protocols, for example, but sources can easily be biased or manipulated. They might look random, but maybe they're not. And again, it's really hard to look at a value and say yes or no. In addition, existing solutions are really hard to scale, and they lead to things that are very expensive to use and really slow to use. And we'll get to that more in a little bit. But all in all, randomness is critical for Web3, and even more critical for security in general. For example, in 2013, both Microsoft, Apple, and Oracle simultaneously had issues due to random number generation, which led to millions of dollars of losses. Obviously, that's Web 2. And more recently, in 2021, there is an issue found in insecure randomness number generation in IoT devices, which impacted over 1 billion of them. They caught it soon enough to not cause problems, but that's a $300 billion industry that could have been completely exploited due to insecure randomness. And also in Web3, randomness enables fair protocols. It really enables fairness where each participant is given the same opportunity. For example, in voting and governance, randomness can be used to allow fairness in your choices of candidates. It can enable unbiased distributions for example, for airdrops, for NFT minting, and more. Beyond randomness, we also introduced time lock encryption, which just keep that in your mind a little bit. We'll get to that in a second. So according to Fortune Business Insights, by 2028, we estimate that randomness and the need for secure randomness will reach a $2 trillion total available market. And that's because, as you can see, it touches nearly everything. Everything we do online needs randomness. So in the Web3 space, we see in gaming to enable fairness, in DeFi, gambling, betting, and especially in voting and governance. Obviously, beyond that, there's IoT, as I just mentioned, but also telecommunications, messaging, healthcare, pretty much everything. Without it, everything can be exploited. And we estimate a $600 billion SAM currently, and a $3.5 billion SOM. Our initial major approaches for this, and the major systems that require secure randomness currently, is Web3 gaming, DeFi, and blockchain infrastructure. For example, consensus systems, proof-of-stake ones that leverage secure randomness. So to address these concerns, we've developed the ideal network. Again, that's the interoperable, decentralized entropy aggregation layer. So essentially what we're trying to enable is a sharded single data structure that can integrate randomness from many different sources. And this is called our entropy mesh. To do this, we've also developed what's called an interoperable randomness beacon. This is similar to existing randomness beacons, for example, DRAND, except it follows the NIST's protocols and specifications. So NIST is the National Institute of Science and Technology in the United States. What we're trying to do is create, again, that single data structure that provides near real-time randomness that's constantly available, always verifiable, and provides a standard that other chains can use. For example, through XCM or through RPC. There are multiple ways that we can produce it and consume it. So historically speaking, looking at randomness, block hashes have been used. Bitcoin block hashes specifically, also the pre-Randall opcode in Ethereum. The problem with this is it's very easy to manipulate, making it completely insecure. Additionally, it's not interoperable. You can't say, like, I'm on Ethereum, I want to use Bitcoin block hashes for randomness. That's going to be really hard to do without a proper Oracle system. So they're essentially stuck where they are. And that's a theme that we will continue to see in other solutions. DRAND is probably one of the OG randomness beacons that existed. While it's very secure, it's actually not decentralized. It's a distributed system. So there's no specific incentives for the beacon operators to actually produce good randomness. They do. It is secure. But the other problem is it's very low throughput. Only about every 30 seconds you get a new value, which makes it pretty much unusable for near real-time solutions, such as Web3 gaming. Beyond this, more recently have been the proliferation of VRF-based solutions. That's a verifiable random function. Along with these, we have things like Chainlink, Supra. Also within Polkadot's consensus, Babe uses a VRF. Near Protocol uses a VRF, and a lot more. But the problem is they're not interoperable generally. You either need an Oracle system like Chainlink's Oracle system, or you have to be on that specific chain in order to use it. We also see that even though some of these systems can have very high throughput, that also comes at a very high cost. With Chainlink VRF between $4 to $8 to get a single random value, which is kind of crazy. So the ideal network, we try to check each of the boxes. We're simultaneously decentralized, where we are aiming to be a parachain very soon. We're interoperable in the sense that the randomness we generate can be used across chains, across protocols, within your runtime, and you can always verify it. We also have a high throughput where we can produce randomness with every single block. So right now we have a block time of 3 seconds, so every 3 seconds you get a new, unique, random value that you can verify and compare it to previous values. We also will have a very low cost with even a free tier, although in general, not so much. Our solution is also very secure compared to other solutions. We aim to integrate multiple sources of publicly available randomness into our entropy mesh. And the beauty of this solution is that it means we only need one honest beacon. We could have 100 beacons, 99 could be malicious, but as long as one is honest, we can always produce verifiable randomness. I'd like to, currently we're collaborating with ChainSafe Gaming to research and develop autonomous world capabilities where secure, verifiable randomness plays a critical primitive, acts as a primitive within that ecosystem. With this, we aim to also use time lock encryption, which is another cryptographic primitive we've implemented on top of our entropy mesh. With time lock encryption, you can enable things like sending a message to the future or encryption to the future. And with this, we enable trustless multi-party interactions where we have non-interactive asynchronous protocols between parties. We are currently collaborating to revamp a game that they built on StarkNet to bring it into Substrate using our randomness. In addition, we're also collaborating with the National Institute of Science and Technology in the US. They have developed a interoperable randomness beacon specification that we are currently implementing and which we are going to use to implement our entropy mesh. Which we are currently, they're currently reviewing our code and white papers. So it's hopefully a very fruitful collaboration. Since 2023, we've been developing our solution, where myself and two of the other co-founders met at the Polkadot Blockchain Academy in Buenos Aires. In that same year, we proposed and delivered our first Web3 Foundation grant, where we developed the proof of concept version of our network, which worked at the block authorship layer. In the first 2 quarters of this year, we partnered with the Web3 Foundation's Decentralized Futures program to further enhance our solution. With this, we developed a post-finality gadget that acts as an interoperable randomness beacon. And realistically, any parachain could take this post-finality gadget, make some changes to their client, and actually generate their own verifiable randomness. Along with this, in the next quarter, we plan to continue this development to further develop and enhance our entropy mesh idea. And we're also going to perform security audits before we go live as a parachain, and also further develop our tokenomics, where we will further enhance the external generation of randomness through decentralized and distributed beacons and beacon operators. Looking into the future, we aim to enhance our interoperability outside of the Polkadot ecosystem. So ideally, we'd like to target Substrate-based, Polkadot-based ecosystem first, and then move into the EVM and beyond. We'll also have implementing on-chain governance, and our aim is to deliver randomness to anybody who wants it, be it Web 2, Web 3, or WebX. Obviously, I'm Tony Riemer. I'd like to briefly introduce the team. So I got my start in mathematics at the University of Wisconsin, and I worked in several fintech companies in the US, and then graduated from the PBA, which was pretty much what led to us being here. The rest of the team is, you'll see in the Ideal Network t-shirts right behind you. We all come from various backgrounds where we are able to bring entrepreneurial mindsets, deep understanding of blockchain development, as well as the mathematics that go behind it. I'd like to announce that we are looking for a $1 million pre-seed currently. We intend to use this to continue development of our solution, to ensure the code quality meets all NIST standards, launch our network as a parachain, build strategic partnerships across Web3, DeFi, gaming, beyond. And essentially, we want to secure every protocol we can to provide fairness, interoperability, and pretty much make trustless interactions the norm. All right, thank you, everybody. Here are some links, and that QR code goes to our website if you want to learn more. I think, all right, and we have 1 minute and 45 seconds for questions. Anyone? It's Threshold BLS. All right.
Tony?
All right, thank you.